A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. I welcome you all in our today's online session of applied physics. Hope you all are fine and having good health. We start today's session with some verses of Holy Quran. So coming back to the lecture, in previous session we was discussed about the concept of power. That what is the power? There are three main and basic formula of power, which is we use from Ohm's law. P is equal to V into I, and E is related to the V as well. In previous session, we also make equivalency in between these things. After that, the second formula of power is P is equal to I square into R, and the third formula of power is E square upon R, which is the V square of R as well. After that, we've all discussed that from the meter to measuring current, and what is the formula, what is the way that how to find the current in a series circuit, and the in series circuit the current is same, and the way by which we need to measure the current is to open a closed circuit and connect a ammeter from ohm meter by selecting the ammeter by selector switch, and then connect in between these in series of the circuit, then the current would be appear on that analog screen as well. So this is the way that how to measure the current in a series circuit, and it is not mandatory to connect that meter in the end of circuit. We can also be connect that meter in the first part from the positive side of a circuit, then current would be same, because in series circuit we all know the current is same. If we need to connect that meter in this way in between the battery and first bulb of load instead of the last one, then the current would be same, because the current is same in the whole circuit if the notation of load connect in series. Now from the meter, if we need to measure the voltage, then we need to connect the voltmeter by selecting that voltmeter from voltmeter selector switch. Then the particular voltage would be form appear on that analog screen or digital screen of the meter, but we need to connect that meter probes in parallel without disconnecting this cable. Either it is the first one, either is the last one. So to measure the voltage, we are not need to open the circuit. We only just connect these particular probes to the load, then the voltage would be appear on that screen. So this is the way that how to measure the voltage from the meter. Now the third category of the parameter is the resistance, and how we connect or measure the value of resistance from a digital or analog multimeter, ohm meter. Then first we need to understand the ohm meter. So measuring across the resistor, but be sure the circuit is not turned on hot. So we need to first normalize the particular circuit. Put in the known voltage and measures the current. So it requires a battery. If the circuit is energized, will give the wrong reading. So that's the reason we need to follow the SOPs. Never leave a multimeter set at ohms, will run down its battery. So always disconnect or off the meter if we not need to use, specifically for the digital meters, because they are continuously energize if you on the meters. But analog meters, if cannot be used, then we also be off it as well as digital, then your battery would be safe. So changing a range of meter, first we need to, there are many ways by which we can calibrate or change the value of meter. So first to understand the voltmeter or ammeter, before that we need to the measure the value of voltage from voltmeter. But before that we need to understand the ohms of the resistor, how we can find from the meter. So it's the same way that to measure the resistor. Imagine that these are the three resistors are connected in series like a load of bulb. Then if we need to connect these prop of multimeter from particular resistances, then the resistance would also be appear on its resistance scale of meter, but we need to select it from selector switch. Then resistance would be found. So this is the way of measuring resistance as resemblance like to measure the uh, voltage. Okay, so this is the technique by need to measure the resistance of a particular resistor which is connect in a circuit. Now coming back to the voltmeter, this is the analog meter on which the scales of digits are mentioned here, that how much the value of voltage is moving further. So these are the scales of 0 to 5 volt, and by changing the range it would be transformed to 0 to 10 volts. uh, Multiplier resistor connect to here to extend its range by using the multiplier resistor. After that, the pointer, which is the needle deflection base, which is worked by how much energy is uh, creating or measuring by the device, then how much of voltage, then the reflection would be form in greater. And if the range of particular voltage is less, then the value of voltage would be less by the less deflection of scale of pointer. So this is a battery which is connected through a lamp and energize the lamp. And if we need to measure the voltage of battery, then we need to connect it parallel with the meter. Then voltage which have the battery appear on the voltmeter needed deflection. So this is the way that how to measure the voltage and all about the voltage related to the measuring device of meter. After that, the second category of meter, which is the ammeter. Uh, Same both. I'm also giving the background theory of the meters, which is the galvanometer. So galvanometer is a device. Galvano is a name of a scientist by which it devoted to its name by the meter, which is the galvanometer. Galvanometer is a device which is used to measure the sensitive amount of current. And if we need to transform the voltmeter, then if we need to connect parallelly connect to the resistor, to the galvanometer, it will be transformed to the voltmeter. And if we connect the shunt resistance in between, in parallel, sorry, in series, it will be transformed to voltmeter. And if the shunt resistance, which is a low resistance, connected in between parallel to the galvanometer, then it will be transformed to the ammeter. So this is the main science behind to calibrate or make a meter of a single entity of galvano into a particular ammeter, voltmeter, respectively. Then this is the way. So if we need to connect a galvanometer to the shunt resistance, which is the low resistance in parallelly connection, then that galvanometer would be named as a ammeter. So this is the way that how to transform a galvanometer into an ammeter. Okay, if we need to connect, uh, if we need to measure the ampere of the particular circuit, then how much current is drawn by this lamp. So we need to connect that meter in series of this circuit, and series in between, uh, connect the ammeter in between series of battery and lamp, then ampere how much drawn would be appear on that particular needle of deflection. So this again, all these things are scale, pointer, and shunt resistance we already discussed, and lamp and battery are the same thing. So this is the way that how to change, how to mention or measure the value of this thing. And after that, it will also be transformed into a high range value. Schematic symbol of examples. These are the commonly used symbolic representation in electrical electronic based device designs and drawings. So this symbol is related with the chases ground, earth ground, antenna, variable resistor, fixed resistor, fuse, single cell battery. It looks like in this form. And if we have the multiple cell of battery, then it will be transformed from this symbol to this one. Single pole, single throw switch would be looks like this way. And single pole 6-position rotary switch, which is the uh, meter selection phenomena, or phase selector switches can also be the example of this one. So if we need to select particular 6-pole positions by a single entity of meter or the mechanism, so it will be looks like in this way. Single pole double throw, so double but single throw, single pole and double throw. So single is the pole and the double is throw. And double pole double throw, it would be looks like this way. So these are the some of application of this relay. This switch is in relay device, which is the electronic AC or DC relays. So these are some schematic symbol example representation in schematic diagram, symbolic representation of diagram, and electrical electronic wiring diagram are the symbol which is related to the particular phenomena. Further, schematic and block diagrams also be used there. So the symbols which are discussed in our previous slide, so are applicable here. And what are the symbols? Resistor have symbol, and as well the capacitor, inductor, diode, transistor, all 5 symbol can also be reflected in this diagrams. So these are the applications now further in drive devices and drive applied phenomena of electronics, electronic based component in these kind of schematic diagrams which we use out there. So moving and starting the schematic block diagram further, the schematic diagrams include all the individual components and how they are connected. So this is the some kind of radio receiving microphonic uh, schematic diagram of card or some kind of circuit which receives sound wave from a fixed plate of microphone vibrating plate diaphragm, which is catch the sound waves, which is the capture the sound wave by this two lines, and further the variable capacitor connect through it, which we already discussed in our previous slide. The inductor also be out there. So combination of these two things are the tune circuit, and we call also said this it's a choke circuit. After that, the polar capacitor is connect out there, which is the positive and negative further. And after that, the resistor for the ground, and the supply DC supply towards from this side, but capacitor with earth grounding. Further, the supply of DC in between the resistor inductor are provided from there, which is the energizing part of base as well, and toward the collector as well. So base, if we provide supply from the base side, then the collector to emitter supply would be fulfilled, and circuit uh, is energized, transistor is energized, and signal can also be thrown from this side. After that, from the collector side, the frequency multiplier also be connected there, because due to the uh, lower range of frequency, after the multiplier it would be high in range, and after that we connect the power amplifier to boost its gain, and then further we receive the signal through the antenna. So this is the way that how a microphone is worked, and we connect the amplifier and send further towards the antenna, and further the someone receive that signal, like an application at this one. That's if a signal is sent from the antenna, then receiver would be received from this side. As an example, we can say that microphone received the signal. Further, transceiver is a device which can also be transmit and receive the signal, so it is called the transceiver. So SWR, to signal to voice ratio, meter can also be out there. Antenna switches are connect out there, and antenna receive that feed line of signal, and dummy antenna can also be connect out there. So these are the applications in of electronics or electronic devices in applied physics. And all these components which we discussed in our previous slides, lectures, are implemented in this schematic diagram. This is the schematic diagram of component base, and this is the block diagram of electronic based devices. Now coming further towards the application of electronics, which is electronic based component, which is the amplifier. So tubes and transistors amplify signal applied to base or control grid. The amount of amplification is called gain. So transistors have advantages like size, power consumption, cooling, robustness. Tubes have advantages and high power. Further, these are the further applications of base collector emitter, PNP transistor, NPN transistor collector, base and emitter like, and this one is the further the toroid vacuum tube, in which the plate is connect out there, and control grid and cathode is connect out there. So these are the applications. Amplifier had been made by the FET, which is the field effect transistor, and has a gate electrode. The component with an emitter electrode is a bipolar transistor. An integrated circuit is a device that combines several components into one package, and generally including transistors. So most of the ICs are made by many of the drive components, and into a single IC, millions of gates with resistor, transistor, diode, capacitor, inductor are built in this particular chipsets as well as in IC. Typical circuit diagram, these are the further applications: a resistor, transistor, NPN, a lamp, a battery, a chase circuit. So it's a chase circuit. After that, the typical circuit diagram also be, it looks like this. So the main point of the lecture is, if we need to discuss the components of electronics, it can also be used and implemented in many of the electronic devices, electronic cards, electronic instruments, electronic devices. So without these main five particular devices, resistor, inductor, capacitor, diode, and transistor, electronic circuit cannot be fulfilled. This is another one diagram. So these are test equipments. Further, So up till now, if you have any kind of question, query, or difficulty regarding today's session, please feel free to ask. I will answer the kind of question. So if you have any kind of question, query, or difficulty regarding today's session or previous session, please feel free to ask. I will answer the question and resolve your queries if you have in your mind. Otherwise, we end today's session.